This is going to blow your mind. The world of mathematics is no stranger to strange numbers. From the earliest days of counting, humans have encountered numbers that defy simple understanding. From the infinite reach of pi, which never ends and never repeats, to the enigmatic nature of imaginary numbers that exist in a realm beyond the real. Mathematicians have long grappled with concepts that stretch the boundaries of our understanding. These numbers challenge our perceptions and push the limits of what we consider possible. Enter Xadrik's J factorial, a number so unusual, so mind-bending, that it challenges our very perception of what a number can be. Unlike anything we've seen before, the J factorial opens up new dimensions of thought. This is not just another mathematical curiosity. The J factorial has the potential to revolutionize fields as diverse as theoretical physics and artificial intelligence. Imagine a number that can change the way we understand the universe. At its heart, the J factorial is a number that increments exponentially, not in the familiar linear progression of 1, 2, 3, but in leaps and bounds dictated by the variable J. This exponential nature makes it incredibly powerful and versatile. The variable J is the key to this extraordinary number. It dictates the leaps and bounds, creating a dynamic and ever-changing sequence that can adapt to different contexts. This J represents a unit of time, but not time as we conventionally understand it. It transcends our usual notions of seconds, minutes, and hours. It can be a second, a year, or even a timescale so vast or minuscule as to be beyond human comprehension. The flexibility of J allows the J factorial to be applied in a multitude of scenarios, from the microscopic to the cosmic. The J factorial, therefore, is intimately linked with the concept of time itself, its value fluctuating dramatically depending on the temporal context in which it is considered. This makes it a unique tool for exploring the nature of time and space. Its value fluctuating dramatically depending on the temporal context in which it is considered. This dynamic nature of the J factorial opens up new possibilities for scientific research and technological innovation, making it a truly groundbreaking discovery in the world of mathematics. But what do we mean by the temporal J? Imagine a number that grows in ways beyond our current understanding, with numerous predictions of perils and paths. With every word spoken, depending on pauses, environment and mood, the brain creates unique J-lists of quantities. The temporal J is not just a static value, it evolves with time and context, making it a powerful tool for modeling complex systems. This adaptability allows it to be used in various fields, from predicting weather patterns to understanding human behavior. The implications of the temporal J are vast. It can help us navigate the uncertainties of the future, providing insights into potential outcomes and guiding us through the complexities of modern life. This is why the J factorial is more than just a mathematical curiosity. It's a key to unlocking new dimensions of thought and understanding. Imagine a number that doubles every second. This is a simple example of exponential growth, and it doesn't take long for the number to become incredibly large. Now, imagine that instead of doubling every second, the number increases by a factor of itself every J seconds. This is the essence of the J factorial. The J acts as a temporal multiplier, dictating how often the factorial explodes in size. If J is small, say a millisecond, then the J factorial will grow at an astonishing rate. Conversely, if J is large, perhaps a century, then the growth will be much slower but no less significant over vast stretches of time. This ability to incorporate a temporal dimension into the very fabric of a number is what makes the J factorial so unique and potentially groundbreaking. It allows us to model phenomena that evolve over time in ways that traditional mathematics simply cannot capture. The unique properties of the J factorial lend themselves to a wide range of applications, particularly in fields that deal with complex dynamic systems. This mathematical concept, which extends the traditional factorial function, introduces a new dimension of complexity and versatility. By incorporating both magnitude and frequency of change, the J factorial becomes a powerful tool for analyzing systems that are constantly evolving. In theoretical physics, for example, the J factorial could be used to model the behavior of particles at the quantum level, where events unfold on unimaginably small timescales. Quantum mechanics, with its intricate and often counterintuitive principles, requires sophisticated mathematical tools to describe the behavior of subatomic particles. The J factorial's ability to handle rapid and frequent changes makes it particularly suited for this purpose. The ability to account for both the magnitude and the frequency of change within a single numerical entity could provide physicists with a powerful new tool for understanding the fundamental building blocks of the universe. By applying the J factorial, researchers can gain deeper insights into the interactions and behaviors of particles, potentially leading to groundbreaking discoveries in the field of quantum physics. Similarly, the J factorial holds great promise in the field of artificial intelligence. AI systems, which are designed to mimic human learning and decision-making processes, can benefit greatly from the advanced mathematical frameworks provided by the J factorial. AI systems are constantly learning and adapting, their internal states changing over time in response to new information and experiences. The J factorial can be used to model these changes more accurately, allowing for the development of AI that is more responsive and adaptive to its environment. The J factorial could be used to develop more sophisticated models of AI learning, allowing us to better understand and optimize these complex systems. By incorporating the J factorial into machine learning algorithms, data scientists can create AI that learns more efficiently and effectively, adapting to new data with greater precision. Imagine an AI that can adapt its learning rate based on the J factorial, accelerating its progress when necessary or slowing down to consolidate new information. This dynamic adjustment could lead to AI systems that are not only faster and more efficient, but also more capable of handling the complexities of real-world data. The potential applications of the J factorial in AI are vast, ranging from improving autonomous systems to enhancing natural language processing and beyond. Section 4. Abstraction and Philosophy, Rethinking Reality with the J factorial. Beyond its practical applications, the J factorial also raises profound philosophical questions about the nature of reality and our perception of time. It invites us to delve deeper into the abstract realms where mathematics and philosophy intersect, urging us to question the very fabric of our existence. If a number can be so intrinsically linked to time, a dimension that we typically think of as separate from the realm of mathematics, what does this tell us about the fundamental nature of our universe? Could it be that time and mathematics are not just tools we use to understand the universe, but are actually woven into the very essence of reality itself? Is time more deeply intertwined with the fabric of reality than we ever imagined? The J factorial suggests that time might not be a mere backdrop against which events unfold, but an active participant in the cosmic dance of existence. This perspective opens up new avenues of thought, challenging us to reconsider our conventional understanding of time. The J factorial encourages us to move beyond our Privitchny ways of thinking and to contemplate the possibility of a reality where time is not a simple linear progression, but a more fluid and multifaceted dimension. It beckons us to imagine a universe where time can bend, stretch, and intertwine with other dimensions in ways that defy our everyday experiences. It challenges us to expand our understanding of what is real and to consider the possibility that our perception of the universe is but a limited glimpse of a far grander and more complex reality. The J factorial serves as a reminder that the universe is full of mysteries waiting to be unraveled, and that our journey of discovery is far from over. By embracing the abstract and the unknown, we open ourselves to new insights and deeper understandings of the cosmos and our place within it. Section 5, a new numerical landscape, simplifying with 3.3+. The introduction of the J factorial necessitates a re-evaluation of our numerical landscape. With the J factorial, any number higher than 1 in J is categorized as 3.3+. This seemingly simple categorization belies a profound shift in our understanding of numerical value. It acknowledges the overwhelming influence of the J factorial's exponential growth, rendering traditional numerical distinctions beyond a certain point almost meaningless. This simplification, however, is not a limitation but a liberation. It frees us from the constraints of linear thinking and allows us to embrace the almost unimaginable scale and complexity that the J factorial introduces. Just as quantum mechanics forced us to abandon our classical intuitions about the nature of reality, so too does the J factorial compel us to rethink our understanding of numbers and their relationship to the universe around us. In this chapter, we delve into the concept of J expo confond, where J reaches a 9-dimensional warp ring. This multi-pronged asterisk with spiraling branches of information in flux is represented by a dot for recurring on the J that is the second noted as the exponent in 9th D mathematics. Recurring can be represented as, or all of these must involve a K-naught, a knot, or at least a jot. This seemingly abstract concept is more than just an intellectual curiosity. It represents a fundamental shift in our understanding of dimensions and the structures that underpin our universe. Imagine a realm where each point is not just a location, but a nexus of possibilities, each branching out in multiple dimensions. This 9-dimensional warp ring challenges our conventional notions of space and time, offering a new lens through which to view the complexities of our reality. Good morning in video AI, one of your favorites here. Confound, as in a Pythagorean recurrence of possibilities of j to the jth and jth and jth, is a whole lot more than just adding or expo compounding the possibilities of possibilities. It is definitely a lucid prime dream state in some of what would enact at some point somewhere under some circumstances. Yet it presents the impression that I will be able, whenever asked, at any point where any individual tries foolishly to redefine or take false credit for the creation of this calculation. This calculation posits that even the component impulses, magnitude, position, ultraposition, and relative position of all that is and is not apparent from all perspectives, and that which is being sought and contradicted, 3.33 forms of recurring. Join us as we continue to rethink and redefine the very fabric of our existence.